Section 5.4, Systems of Nonlinear Equations in Two Variables. A system of two nonlinear equations in two variables is also called a nonlinear system. Contains at least one equation that cannot be expressed in the form of ax plus by equals c. Here are some examples. So here we have a nonlinear system because one of the equations is not aligned. So here's that one right there. Here we have a nonlinear system because both of these are not lines. Okay. Just for your reference, this is going to be a parabola, which is what we dealt with in chapter 3. This is going to be a parabola. And a circle right here. This is a line. Okay, so a nonlinear system has at least one equation that cannot be written in this form, which basically means it's not a line. Since the graphs can be circle, parabolas, or anything other than two lines, the solution set is a set of all ordered pairs. Okay, so something like this would be like if I had a circle. Okay, so here's my Cartesian plane. Let me go ahead and write this circle real quick. If I had a Cartesian plane and I had a circle and then a line, the solution set would actually be these two ordered pairs right here and here. I could also have a parabola and a line. The solution set would be these 2 points here. And there are many more cases. I could have a circle and a parabola. So I could have a circle and a parabola. I could have parabola and parabola. There's lots of different cases. I could have, so anyway, I won't draw them all. But so anyway, the solution set is a set of all ordered pairs. So let's go to example 1. And how do I solve a system of a nonlinear system by the substitution method? Well, it's very similar to solving linear systems. We want to make sure we have one variable by itself or isolated. So we look at the system here. The one that's easily isolatable would probably be this y right here. Like over here, and I have this 3x minus y equals 9. I can go ahead and subtract 3x from both sides. So I get negative y equals 9 minus 3x. And if I divide both sides by negative 1, I would get y equals, and if I divide the negative 1 into the 9, I get negative 9. If I divide the negative 1 into the negative 3x, I get plus 3x. Okay. Now I'm going to take that value, and I'm going to substitute it into the y into the other equation. So I'm going to put it right into here. This now becomes x squared equals 2 times negative 9 plus 3x plus 10. I get x squared equals negative 18 plus 6x plus 10. I get x squared equals negative 8 plus 6x. Now I need to solve this equation, and second degree equation, so I'm going to go ahead and set this side equals 0. I get x squared minus 6x plus 8, and notice how I got that in order with descending powers. So I added 8 to both sides and subtracted 6x to both sides. I factor this. I get x equal, or x minus, the minus is 2 times 4, minus 4x minus 2. Would that be the right one? X squared minus 2x minus 4x negative 6x plus 8. So x is going to equal 4 or 2. Okay. So now we got to find y. So to find y, we have two values for x. So to find y when x equals 4, we can put this x value into this equation, or this equation. Probably easiest to put it in this equation right here. So y is going to equal negative 9 plus 3 times 4, which is equal to negative 9 plus 12, which is 3. So I get the point 4, comma 3. Now I want to find y when x equals 2. So I get y equals negative 9 plus 3 times 2. So y equals negative 9 plus 6. So y equals negative 3. With 2, negative 3. Okay. So what it's basically saying is I have a parabola and a line. So the parabola, whatever it looks like, and a line. And the 2 points that it intersects are 4 comma 3 and 2 negative 3. Now again, like we discussed before, you can check your solutions. If I put 4 and 3, it better work in this equation and this one. That would give me what? 16 equals 6 plus 10, which is 16. That works here. 4 and 3, this would be 12 minus 3, which is 9. It works in here. Now I plug in the 2 and the negative 3. This one works. 2 and negative 3, this would give me 4. This would give me negative 6 plus 10, which is 4. Put the 2 and negative 3 here. 2 would be 6 plus 3, because I minus the negative 3 is plus 3, gives me 9. So this one checks also. Let's do another one. We're going to solve this system by the substitution method. And we're going to go ahead and, again, there's 2 variables that are going to be easily isolatable. And I'm going to go ahead and isolate this x because the leading coefficient is 1. That gives me x equals 3 plus y, or y plus 3. I'm going to add y to both sides. Now I'm going to take this value and put it in for x into this equation. This gives me 3 plus y minus 2 squared plus y plus 3 squared equals 4. This gives me y plus 1 squared plus y plus 3 squared equals 4. Okay, and then I'm going to go ahead and FOIL this out and FOIL this out. I get y squared plus 2y plus 1. Again, all I did was do y plus 1 times y plus 1. That's where I get this from. That's where the 2y comes from. Plus y squared plus 6y plus 9 equals 4. Again, I just wrote y plus 3 times y plus 3 and FOIL that out. So I'm going to write that. So now I get 2y, when I combine like term, 2y squared. This gives me plus 8y. And 1 plus 9 is 10 plus 10 equals 4. So 2y squared plus 8y, subtract 4 from both sides, plus 6 equals 0. It's secondary equations like that one side equal to 0. So this side, the right-hand side is equal to 0, so I'm going to go ahead and factor the left-hand side. Notice how the greatest common factor, I can pull out 2. So I get y squared plus 4y plus 3 equals 0. And if I'm going to bring this up here, I get 2. And if I factor out this right here, I get y plus 1, y plus 3. The y would equal negative 1 or negative 3. Let's find x. So to find x when y equals negative 1, you can plug that into here or here, but it's probably easiest to check in here, or I mean put in there. So x equal to 3 plus a negative 1, so x equals 2. I get 2 negative 1. And then to find x when y equals negative 3, I get x equals negative 3 plus negative 3, which is 0. So I get 0, negative 3. So again, we can check these back into the original system. 2 and negative 1. The 2 minus the negative 1 would be 2 plus 1, which is 3, so it works in the first one. And I put 2 and negative 1 here. Well, this would give me 0, squared, that's 0, and then negative 1 here would give me 2, and 2 squared is 4. So this one checks in both. When I check 0 and negative 3 in here, 0 minus a negative 3 is 3. I put 0 and negative 3 in here, this becomes negative 2 squared, which is 4. And then the negative 3 here makes that 0. So 4 equals 4. This one works also. Okay, so I didn't physically show the check, but I went ahead and checked it anyway. On your own, go ahead and solve the following two problems by the substitution method. And there's one on this page and the next page. And when you get done, check your answers with mine. Go ahead and pause the video and do the problem and then check your answers. Okay, so the on your own problem, the first one, I did two ways because I'm not sure how you would have solved it. So I did one where I isolated y in the top equation, and that's the work over here. And I did another way where I isolated y in the bottom equation. So either of those y's would be easily isolatable. I get the same answer in both of them. I get 0, 1, and 4, 7 as my solution. And I actually checked 0, 1 in the top one and the bottom one. I checked 4, 17 in the top one and the bottom one, and it also worked. So I think for most of y'all would either solve for the y on top or the y on the bottom. And so check your work on whichever one you did. And then for the second on your own part B, I think the only variable isolatable or easily isolatable will be the x on top. So I solved for x and got negative 2y and put it into the second equation. And that gave me negative 2y minus 1 and that entire thing squared. So I wrote that twice, multiplied it out, and got this. And then I followed out the y minus 1 squared, got that. And I ended up with second degree equation. And I set it equal to 0. And so here's the second degree, here's the second degree equation I got. 5y squared plus 2y minus 3 equals 0. And so I ended up factoring that. And the 2y values I got were 3/5 and negative 1. And then I went ahead and found x for those two values there. And then these are the two solutions. Okay, I'm getting ready to run out of time for the example 3, so I'm going to stop the video here. And then the next part we'll go ahead and start example 3.